Welcome to the second class of this week. In this class, you will learn the different ways to estimate the age at death in adult individuals. As we already seen last week, the age at death estimation in adults is almost exclusively related to the degenerative changes. And it isn't totally done with degenerative changes because there are final stages of development of the skeleton in the second decade of life. And I'm talking about the fusion of the alia crest and the fusion of the sternal end of the clavicle. The degenerative methods are based in changes that occur in articulations with little or no movement, like the cranial sutures, the pubic symphysis, the auricular surface, and the sternal end of the ribs. We will start by seeing the final stages of development of the skeleton. And unlike in non-adults, the age ranges in adults are bigger. So the first final stage of development that I'm going to talk about is the alia crest. In this image you see a cruciate and you can see this line here that means that the alia crest was fusing at the time of death. And we know that this happens between 17 to 23 years old. About the sternal end of the clavicle, you see these three images here that they are a sequence of the fusion of this epiphysis. And here in figure E, you can see that the epiphysis is completely fused, which means that the individual has more than 29 years old. When these two epiphyses are completely fused, they are a good indicator that the individual is an adult. And when they are still fusing, we can look at the methods that tell us the development of the alia crest and the sternal end of the clavicle and get an age range. And now we are going to start by seeing the methods based on the degenerative changes. As I said last week, they are very variable because the degenerative changes can be affected by a lot of different factors such as genetics, environment, and physical efforts. The first method is using the closure of the cranial sutures. It is known that the cranial sutures closes with age. However, this is very variable between people, and because of this method isn't very used. I'm only going to show you shortly how this works. So, in this image, you see a progression of the closure of the sagittal suture. In image A, it is the younger individual, and in image D, it is the older individual. In the first image, it is completely open, the sagittal suture. Then in image B, there are some parts that are closed. In image C, a lot of the suture is closed, and in D occurs the obliteration of the suture because the suture closes completely. There are several methods to the closure of the sutures, but in all of them, various suture areas of the skull are scored, and then the sum of the scores corresponds to a very broad age range. One of the methods used to estimate the age at death with the pubic symphysis is the method by Brooks from 1990. The changes in the pubic symphysis continue to occur after full adulthood has been achieved and other epiphyses of the limbs have fused. And it is with these changes that the age is estimated. The young adult pubic symphysis has rugged surface traversed by horizontal grooves. This surface loses relief with age and is bounded by a rim by age 35. Subsequent erosion and general deterioration of the surface are progressive changes after this age. In these images, this one and this one, are the models to each age range. And as you can see, this here and this ages ranges here are very wide. And there are separate models to females and males. Each model has a detailed description to help the identification of the face that we are going to see in the next slides. I will explain you now the 6 phases. So in the original method there are more information about each phase, but I resumed it to be more understandable. So in phase 1, the symphyseal face has a billowing surface and the horizontal ridges are well marked. And as you can see here in this image, you can see that the ridges are very well marked. Then we have phase 2. And in phase 2, there's the beginning of bone activity at one or both extremities of the pubic symphysis. So this means that in the extremities start to disappear the well-marked ridges. And as you can see here in this zone of this epiphysis, you don't see the ridges anymore. But the rest of the surface is still possible to see some ridges like here and here. Then in phase 3 happens the same that was happening in phase 2. So there's the continuation of bone activity that starts to expand to the ventral border. So as you can see in this image, this part, the extremity, it hasn't already the ridges, and also now this part doesn't have them also. In phase 4, the symphyseal face is generally fine-grained, although remnants of old ridges and furrow system may still remain, and the symphysis has a distinct rim. So in this image, it's still possible to see some remnants of the ridges, but then you see clearly here the rim of the epiphysis. In phase 5, there's moderate lipping on the dorsal border with more prominent bone outgrowths on the ventral border. And the lipping is basically bone that grows around an articulation, and you can see this bone grows in this zone of the epiphysis. And finally, in phase 6, the face of the epiphysis may be pitted or porous, giving an appearance of disfigurement. The shape of the face is often irregular at this stage. So in this image you can see clearly that the symphyseal face lost its original form and now it's irregular. So now I'm going to give you 2 examples of how to apply this method. So in this first example we have this pubic symphysis here, and we can see clearly the ridges in the surface, so this means that it is between phase 1 and phase 2. In phase 1, the symphyseal face has a billowing surface and horizontal ridges well marked, and looking at this epiphysis it corresponds, but we will see the phase 2. So in phase 2, the extremities of the pubic symphysis have some bone activity, and looking at this epiphysis, we can see any bone activity in these extremities. So this means that this epiphysis corresponds to phase 1. Once it's a female individual, we have to look at the age ranges of the females, and that gives us with an age range with a final age range of 15 to 24 years old. So now another example. In this case, we can see any remnants of the ridges, so it tells us that it is or phase 5 or phase 6. So in phase 5, the face of the pubic symphysis have lipping with bone growths, and we can see that in this image, the pubic symphysis has these characteristics. And then in phase 6, the face may be pitted or porous, and we don't see any of this in this pubic symphysis. Also in phase 6, the shape of the face is usually irregular, and in this image we can still see the original form of the pubic symphysis. So this way, this pubic symphysis is probably in phase 5, and that corresponds to an age range of 25 to 83 years old. The auricular surface of the ilium has been shown to be a reliable indicator of age in older individuals, regardless of sex or ancestry, and the auricular surface is this part here of the cocci. In comparison with the pubic symphysis, the auricular surface is more likely to be preserved in forensic and archaeological skeletons, given that the pubic symphysis is a fragile zone of the cocci. The method that I will present you is by Lovejoy and collaborators from 1985. This method describes age-related changes in surface granulation, microporosity, transverse organization, billowing, and striations. These changes are somewhat similar to the ones that occur in the pubic symphysis. As well as the method of the pubic symphysis, this method is divided into phases, which is 8 phases, and each one corresponds to an age range, and each one has reference images and a description. So in the first phase, the auricular surface is billowing and has very fine granularity. In this image 1, you can see in the zones here the billowing. In the next phase, there's a reduction of the billowing, but retention of youthful appearance. And if you look at image 2, you can still see some striation, but it is different from phase 1. In phase 3, there's a general loss of billowing and replacement by striate and distinct coarsening of granularity. If you look here at this image that corresponds to a phase 3, you can see in the zones here the granularity and then here the striation. And then in the phase 4, there's a uniform coarse granularity that you can see clearly in this image. So in phase 5, there's a transition from coarse granularity to dense surface. And you can see here in this image that there are some zones that it has some granulation, but then here it is very dense. In phase 6, there's a completion of densification with complete loss of granularity. And if you look here in this image, you can see any granularity, so the surface is only dense. In phase 7, dense irregular surface of rugged topography. So you can see here that this is very irregular in this zone. And in the last phase, there's a breakdown with marginal lipping, as you can see here in this part, microporosity and increased regularity, as you can see in this zone. So now we are going to try to estimate the age at death with this auricular surface. So we don't see any billowing, which means that we can exclude phases 1 and 2. Looking at phase 3, in this phase we have striation, coarsening of granularity. And we can see the granularity, but we don't see any striation, so it can't correspond to this phase. Now looking at phase 4, there's a uniform coarse granularity, which is what we see in this image here in this zone. And at phase 5, there's a transition between coarse granularity to dense surface. And if we look at these zones, for example, here and then here, we see that they are dense, but the rest of the auricular surface still has granularity. So this means that this auricular surface is in phase 5, giving an age range of 40 to 44 years old. To finish the age at death estimation, I will present you a method that is based in the sternal rib end. I'm not going to explain this method because it isn't used often. His son and collaborators in 1984 described the 3 components of age-related change at the sternal end of the 4th rib. Their 6 number stages were described for each of these components, and this method depends on both the preservation and positive identification of the 4th rib, a situation that is difficult and/or uncertain in many archaeological contexts. And this is because the ribs are very fragile bones and are susceptible to taphonomic destruction. But we'll talk more about this in the next week. In this sequence of images here, you can see phase 0, phase 2, and phase 5. And you can see that the hand here is almost perfect, and then here it has a lot of changes. So, in the next class, we are going to talk about stature. If you have any questions, please let me know, and I will see you in the next class.